All right, so hello everybody and welcome to this session of polynomials. Now, we're going to be covering this chapter in 3 parts, and this is going to be the first part of the 3-part series, of course. So there are plenty of concepts that we are going to be covering today, but first I'm going to see who else is present here. All right, so who all is present here? Anchal says hello, Chitra says hi, good evening says Tatleen. All right, so you guys are pretty excited. Yes, awesome. We have Prashansa here, we have Vedika, good evening. A very good evening to all of you as well. Archit, we have Rashmi, we have Venkat Ramana, we have Upadhyaya here as well. Rashmi, all right, good evening to you as well. We have Tanvi here, good evening. Yeah, all right, awesome. So you guys are pretty excited about this. I'm sure you are. Firstly, what I'm going to do here is all right, Rahul and Archit as well. All right, before I begin, just quickly let me know if I'm perfectly audible and visible. Yeah, so that we can begin this session. Just land up a few quick thumbs ups in the comment box and I'll understand. I'm doing good, Rahul. I hope you're doing great as well. So Bhavya, yeah, I'm doing awesome. Thank you for asking. I hope you guys have had a pretty good day today. Yeah, thank you so much for landing those thumbs ups. So I'm perfectly audible and visible, I believe. Yes. So first thing that I'm going to do here is show you what all concepts we are going to be covering today. Okay, so these are going to be pretty important. First thing, we will start off by introducing what a polynomial is. And then there are some terms that you guys should be aware of, like what is a coefficient, what is a variable, what is a constant, and you know, all of that. So all of those terms and terminologies would be taken care here. And then the degree of a polynomial, a fairly simple concept, we will cover that up. Then the number of terms, okay, how do you classify a polynomial based on the degree? How do you classify the polynomial based on number of terms? The value of a polynomial, and then we will wrap the session up by looking at the idea of zeros of a polynomial. All right, so let's start the session now by first letting you know about, yes, the Byjus classes 2 teacher advantage. It can't get better than this because home tuitions now are finding the right tuition, of course, has gotten pretty simple here because map to your school curriculum, the first best advantage of this, yeah? And then you get to choose your own class timings, and all of these ideas here, you know, the personal attention, one-to-one guidance revolve around personalization, one-to-one attention being given to you, because teaching a concept, you know, it happens, but then unless and until your doubts are being clarified on that concept, you know, no matter how simple they are, no matter how complicated they are, that's when real learning happens. All right, so do try it out. It starts as low as 199 rupees. The link to all of this could be found in the descriptions box, so make sure you give it a try. I'm sure you guys are going to love it. Yep. And the next thing I want to talk about, again, for the new students who have joined us through this video, is the Telegram channel. Again, the link to this could be found in the descriptions box. Make sure you join it because on the Telegram channel is where we share the session notes with the teacher's handwriting. They are going to come pretty handy if you want to revise all these concepts later on. Okay, and invite your friends as well for this session. That'll be great. All right, as I said, we're going to start by introduction of a polynomial. Now, guys, remember there are plenty of concepts that we are looking to cover in this session today. They are going to be really important considering the perspective of your grade 10 as well, right? So make sure you understand all of it really well today. Okay, so give me your best concentration, yeah? So come on, algebraic expression, first thing. It is a combination of what? 2 important terms here. It's a combination of variables and constants which are linked by mathematical operators. Yes? So what is a variable? I'll explain you that. What is a constant? I'll tell you that. And what are mathematical operators? I mean, this you already know of it. Mathematical operators are plus, minus, multiply and divide, but division is something that we're not allowed. We'll come to that in a bit, but these are all your mathematical operators, right? These are your mathematical operators. You either add, you subtract, you multiply, or you divide, right? Awesome. So an algebraic expression must contain at least one variable. Now, first thing that I'd like to do here is tell you what is a variable and what is a constant, right? So what is a variable here? A variable is, you generally assign a symbol to an unknown value. It is there, the definition is there in the word variable itself. It varies, it changes, it is not fixed. You do not know about it, right? So that's the reason why any symbol X, Y, Z, A, B, C, D, alpha, beta, gamma, you ought to call to decide what do you want to call a variable. Definition wise, it is something that is not fixed, and we still don't know what that is. So that's a variable. And then what is a constant? Constant is the exact opposite of variable. It is something that is fixed. It doesn't change. Like 3 is going to remain a 3. It's not going to suddenly change to 5 or a 4, right? 7 is going to remain a 7. It's not going to change. So constants are fixed numbers. Variables are something which are unknown, and they can vary depending on, the rules of the equation or whatever you have it. All right, cool. So you've understood what a variable is. You've understood what a constant is. Next thing. Now you have to tell me. Now this is an activity. Now that you've understood it, tell me 2 plus 3, is it a constant or a variable? Come on, type your answers in the comments box. 2 plus 3, is it a constant or is it a variable? What is the difference between variable and constant? Look, variable is something that varies. It changes. And you designate variables by letters, X, Y, Z and all of that. Constant, it doesn't change. Like 2 plus 3, well done. Your answers are absolutely right. 2 plus 3 is 5. It is going to be a constant. Awesome. Next thing. What is 2x? 2x is what? 2x, is it a variable or is it a constant? I think you're still answering the earlier things, constant. All right, Kanika is the first one to answer this. Variable, followed by Bhavya, then Rahul, then Satish, then Jasmita, Vedika, Gaurav, Prashansa. Wow, we're getting plenty of answers here. Archit, Natasha, Neelam, Mona Lisa, Anubha. We have Rafiq here. We have Anchal, Serena. The names are flowing pretty fast, by the way. You have Rahul, Piku is here. All right, Ranjan. All right, cool. So you guys are absolutely right. This is going to be a variable. Why is it going to be a variable? Because x is here. We don't know what x is. It can be 1, it can be 2, it can be -1, -2, whatever. Right? Next thing, 5. Well, this one should be pretty simple. I need not ask you this. This is going to be a constant. X, Y, Z. All of these are going to be variables. And then 1, 2, 3, on and on and on. All of these are going to be constant. So I'm sure if you've understood this really well, constants do not change. They are fixed. Variables are not fixed. They can change, like x plus 3. X is a variable. If x is 1, then the answer is going to be 4. If x is 2, the answer is going to be 5. If x is 3, the answer is going to be 6. So x keeps on changing. We don't know what x is. So that's the reason why it's called a variable. Constant, it is fixed. Well done. Cool. Let's move on now from this. X plus 5, of course, is going to be a variable again. So now that we've understood what a variable is, and we have understood what a constant is, right? So using these ideas, let's try to understand what a polynomial is. Okay, so what is a polynomial? This is an example of a polynomial for you. So polynomial is an algebraic expression which is a combination of variables and constants, okay, which are linked by some operators. All right. Now, what you need to understand, there are a few rules. What is a polynomial? It is a fairly simple thing. What is not a polynomial is where things get interesting. Yes, Kanika, variable can be anything. That's a thing I read just now. Okay, so these are all the operations, as you can see, plus and minus, and these are the variables. So what is the variable here? X to the power 3, x and y. Y to the power 5. So all of these are your variables, and then these powers that you see on top of them, I'm sure you're familiar with the definition, right? This is the power. If there is no power, means what? The power is 1. If I simply have an x here, it means the power on top of x is 1, or the exponent as well. It's sometimes called power, sometimes exponent, both mean the same thing. And then here the power is 5. So quickly I am going to tell you some conditions for polynomials. You've now understood it's a combination of variables, constants, right? So some conditions for the polynomials. Let's check it out. First thing is, look at the powers here. 4, 3, 2, and 1, right? So the first condition for an expression to be a polynomial is the powers of the variables have got to be whole numbers. Okay, that's the first important condition. Remember this. I'm sure you guys know what a whole number is. Whole numbers are what? 0, 1, 2, 3, 4, and it goes on and on and on, right? We'll come to all the details. Okay, let's start from the absolute basics first. So conditions for the polynomial. What is the first condition? The first condition is the power of the variable can only be a whole number, which means 0, 1, 2, 3, 4, on and on and on. Yeah. Coefficients can be anything. Okay, coefficients can be any real number. It's fine. Coefficient can be any real number, but the power has got to be a whole number. Okay, negative exponent is not a polynomial. Coming to that bit now. So let's see how many of you can be able to tell me if the first part is a polynomial or not. So tell me this thing. Is it a polynomial? Is it a polynomial or is it not a polynomial? The first part, which I've just put in a box. Is this a polynomial or no? Come on, type your answers. Alright, the first answer I've got is from Ranjan, then Prashansa says yes, Zarina says no. Come on, Zarina, no. Tell me why no. Yes, alright. Names are flowing pretty fast. Apologies for not being able to read out all your names. Yes, so the answer is going to be a yes. What were the conditions? The conditions were what? The power of the variable has to be a whole number. Yes, what is the variable here? Y. What is the power? 2. Is 2 a whole number? Yes, 2 is a whole number. What is the power of x here? 1. Is 1 a whole number? Of course it is a whole number. Yes, so this is going to be a polynomial. Now you understand why it is a polynomial. Because what have we done here? We've simply checked the power of the variable. Okay, the power of the variable is a whole number. Yes, but this thing, square root of x, how can we write this as? This can be written like x to the power 1 by 2. Right? So this, if I were to rewrite it, it can be written like 3x to the power 1 by 2 plus 6x to the power 1. So the second one is not going to be a polynomial. Why is it not going to be a polynomial? Because the power of x here is 1 by 2 and this is not a whole number. Okay? So now you've understood. First rule is what? The power of the variable has got to be a whole number. The second one, this is the reason why it's not, because the power of x here is 1 by 2. 1 by 2 is not a whole number. Very good. So you guys have understood this. One more example. Can you tell me if this is a polynomial or not? This is going to be a polynomial. Okay. There can be multiple variables, by the way. Yes. Because look, the power of x here is 1. The power of y is 1. The power of z is 1. There are 3 variables here. There are 4 variables here. X, y, z and w. All the variables have the power as whole number, right? So this is the reason why a big yes, this is going to be a polynomial. But this is not going to be a polynomial because, as I said, division is not allowed. Alright, division is not allowed, and this is the reason why this is not going to be a polynomial. Because if I were to rewrite it, look, you've learnt it in exponents, right? 1 by y can be written like y to the power minus 1. Yes, we've learnt in exponents and rules. Like this was a rule, right? X to the power minus n is 1 by x to the power n. So using this rule, y power minus 1 is nothing but 1 by y. So this can be rewritten as what? 6x plus 3 multiplied with y to the power minus 1. This can be written like that. And if I simplify this, this will be 6x power 1, y power minus 1 plus 3y to the power minus 1. So now, look, I've got it in the form, but if you notice, this power here is minus 1, and minus 1 we all know is not a whole number. Yes, because power of y is minus 1. Very good. You've understood this. Well done. Now we move on from this. Alright, so let's try to check some examples. Now if I have a look at the first two, as you can see here, the exponent, look, square root of x can be written like x to the power 1 by 2. So this is not going to be a polynomial. Both of these are not polynomial. I'll quickly go through the answers because I'm sure you guys know about it. And again, 2 divided by y power 3 can be written like 2y to the power minus 3, right? So that's the reason why this is again not going to be a polynomial. But the middle one here, yes, this is definitely going to be a polynomial because the power of y here is 2. Well done. Okay, Anchal has a doubt. What about power of a constant? Okay, it is not going to matter, right? Because I'm coming to that. That's a very good doubt. If you have something like 7 to the power minus 3, this is what? This is simply a number, right? 1 by 343, which you can calculate it. So this is going to be a polynomial. Very good doubt, Achal. I really like that doubt. The power of variable only applies. The power of variable has to be a whole number. Number power can be anything. Like if you have 2 to the power minus 2, I can write it like 1 by 2 to the power 2 which can be simplified as 1 by 4, and you can write it in the form of a decimal as 0.25. Right? So conversions are possible. So number power can be anything, but the variable power has got to be a whole number. Yes? Very good. Cool. Let's move on now. So look, we've understood these two things. We've understood what a polynomial is. So part 1 is done. Right? So again, to give you a short revision, what is a polynomial? A polynomial is an algebraic expression combining variables and constants. The power of variable has got to be a whole number. Very good. Cool. Now let's move on and learn some terminologies. Okay. So what terminologies are we looking at? First thing is an expression. You guys know what an expression is by now. Then what are the terms of these expressions? Let's try and understand that. This is going to be the first term. This will be the second term. And this will be the third term. So how many terms are there? Look, there are 3 terms in this expression. All right. There are 3 terms in this expression. Coefficients. What are coefficients? Coefficients are these numbers. Okay. The numbers which are being multiplied. And constant is just 2. So you got to be very good with these 3 things. What are terms? What are coefficients? And what is a constant? All right. I'll give you another example. And this is even more important. Check this out. 4x cube minus 3x square plus 7x plus 5. All right. So this is my example now. Okay. So how many terms are there? What are the terms? Terms, I'm writing it down here. Terms are going to be 4x cube is the first term. Minus 3x square is the second term. Please be very careful when you're dealing with negative terms. Do not forget the sign. All right. Look, 4x cube is positive. So that's why I write it as it is. Minus 3x square. Okay. If somebody asks you what is the second term in this, don't say 3x square. The second term is minus 3x square. All right. And then the third term is going to be 7x. The fourth term is going to be 5. So there are 4 terms in this expression, the example that I've given you, of course. And what are coefficients? Coefficients are numbers multiplied to the variable. Like let's suppose 3x square. What is being multiplied to x square? 3. So I say 3 is the coefficient of x square. Let's say you have 5y. 5 is being multiplied to y. So I say 5 is the coefficient of y. Yes, that's right, Kanika. 4 terms, it is going to be called a biquadratic equation. Awesome. And you know what constants are by now, right? So we have a very good understanding of what do we mean when we say terms, what do we mean when we say coefficient, and what do we mean when we say constant. Coefficient, Bhakti, I repeat that again, is a number which is multiplied to the variable. Okay? Like another example I could give you is 5x to the power 4. What is being multiplied to 5x to the power 4? 5 is being multiplied, right? So I say 5 is the coefficient. I hope you have understood that. Pretty good. Next. Come on, your turn now. Write the coefficients of x to the power 0. Okay, I'm sure you guys know this. X to the power 0 is 1. Yes. Degree, I'm coming to that. Degree will be taken up next. Okay. So first thing that we need to do to be able to tackle this is simplify this. Okay. So 5 plus 4 by 5 x square minus x cube. Right. So this is the expression given to us. Now, I want to, 5 is nothing but 5 multiplied with 1. And in the place of 1, I can write x to the power 0. Yes, I can do that. Can I do that or not? 5 is nothing but 5 multiplied with 1. And in the place of 1, I can substitute x to the power 0. I can do that. Very good. So this can be written like 5x to the power 0 plus 4 by 5 x to the power 2, 4 by 5 multiplied with x to the power 2, plus minus 1 multiplied with x cube. Right? So now, what is the coefficient of x to the power 0? Coefficient of x to the power 0 is going to be 5. Coefficient of x to the power 1, there is no x to the power 1 here, which means I can write 0 multiplied with x to the power 1. Yes? So the coefficient of x to the power 1 is going to be 0. Yeah? X square, what is the coefficient of x square? What is being multiplied to x square here? 4 by 5. And what is the coefficient of x cube? Minus 1. So the answers in order are going to be 5, 0, 4 by 5 and minus 1. Have we understood this, or do you want me to take another example? Have you understood this? The coefficient. Yeah? Because look, 5 can simply be written y minus 1. Okay, Tatlin, very good doubt. You have what here? Minus x cube, right? Minus x cube, which means what? Minus 1 is being multiplied to x cube. That's the reason why I said you've got to be very careful when you are dealing with negative numbers. All right? Look, I'm going to give you another example here. I'll give you another example. Just hang on. Okay, let's just write this thing here. I'm sure you can see this at the top here. Minus 2x cube plus 4x plus 9. In this polynomial, what if I ask you the coefficient of x cube? Tell me the coefficient of x cube. What will your answer be? What is being multiplied to x cube here? Quadrinomial. We'll come to all of those terms. We'll come to all of those terms. Sunil, I'm addressing you there. Minus 2. Right? Very good. Like all of you guys are saying the answer as minus 2. Why do I say that as minus 2? Because minus 2 here is being multiplied to x cube. And that is a definition of a coefficient, right? So the coefficient of x cube, we write it like minus 2, right? But what if I give you this? Minus x power 4 minus x cube plus x square plus 1. I hope you can see this below. Yeah? And if I ask you here, what is the coefficient of x to the power 4? Coefficient of x power 4. Difference between constant and coefficient. Very good doubt, Prashansa. Constant is a number. Like here, 9 is a constant. Coefficient is multiplied to the variable. Alright? But then you can say 9 can be multiplied with x to the power 0. Right? So there's not going to be much difference between a constant and a coefficient. Because I can say the coefficient of x to the power 0 is 9. But then 9 can also be called as the constant. That's a very good doubt. That's a very good question. I'm glad you asked it. Look, when you ask questions like these, the understanding of all of the other students will also improve. Okay, well done. You guys are giving the correct answers. Rafiq, Sunil, Jasmita, Venkata. So the coefficient of x to the power 4 is going to be minus 1 because minus x to the power 4 means minus 1 is being multiplied to x to the power 4. And now you've understood what coefficient is. Yes? Come on now. I'm going to move on to the next bit, which is going to be the degree of the polynomial, like some of your students have been asking that. So degree, guys, is a fairly simple idea. It is not that difficult at all. Highest exponent of the variable. That's all. Alright, like let's suppose I give you this. X power 4 plus 3x cube plus 5x plus 9. Let's take a challenging example. Alright, now the highest power of the variable. Now what is the variable being used here? The variable being used here is x, right? Now let me circle up all the exponents or the powers. The power of here is 4. It is 3 here. No power means what? It is 1, right? So among 4, 3 and 1, which are the powers here, which is the highest number? The highest one is 4, right? So this is the reason why 4 is called the degree of the polynomial. Okay, so now you've understood what is the degree. Well done. The degree is 4. So linear, x means what? I repeat that again. When you are simply writing a variable x, it means the power is 1. Alright, so that's the reason why linear will have a degree 1. Quadratic, you see, the power is 2. So that's why the degree of a quadratic polynomial is 2. Cubic, as you can see, the degree is 3, right? Cool. Constant. Constant is going to be what? I can write just the number 9 can be written like 9 multiplied with x to the power 0 because we know x to the power 0 is 1, right? So the degree of the constant polynomial is going to be 0 because 9 can be written as 9 multiplied with x power 0, y power 0, z power 0, whatever your choice is. Yep. And then the degree is going to be called 0. So you've understood what a degree here is as well. Yes? Well done. Thank you for letting me know that. Awesome. Now the next part is going to be zero polynomial. So zero polynomial is the type of polynomial where coefficients of variable are equal to 0. This is an example. Okay? It is nothing. It's 0. That's all. That is what a zero polynomial is. Like you can go on and on and on because 0 multiplied with anything is 0 itself. This is the reason why a zero polynomial is equal to 0. That's it. Yes, Ranjan. Is there any zero polynomial? Yes, there is. I have come to that here. Look, a zero polynomial is this. But then even if I give you this, like let's say 0 multiplied with x power 1 plus 0 multiplied with x power 2 minus 0 multiplied with x power 3 plus 0 multiplied with x power 4 plus 0 multiplied with x power 5. You know, I can go on and on and on and on, right? There is no end to that. Yeah, because all of it eventually is going to be 0, because 0 multiplied with anything is 0 itself. Yes. So in this case, there is no difference between constant and coefficient. Yes, there's not going to be any difference in this particular case, because constant is this and coefficient, is going to be this. Not in this case, in the earlier case, I'm sure you guys are saying, because here coefficient is what? There is no idea of a coefficient here, because coefficient can be anything. 0 multiplied with 1 is 0. 0 multiplied with 5 is 0. 0 multiplied with 7 is 0. Right? Coefficient could be anything. Yes, I believe you were saying in the other case, in the earlier example that we've taken, where Arka, or I don't remember the who's asked the doubt. Yeah, cool guys. So constant polynomial, you guys know what a constant polynomial is, just a number. Yeah, yeah. If I say 5, it is just a number. If I say 7, it's just a number. If I say the polynomial is 9, it is just a number, a constant. Right? The degree of a 0 polynomial, it is not defined. I'm coming to that in the end. Rafiq Ahmed, that's a good question again. The degree of a 0 polynomial is undefined. Okay? The power is also undefined, because I gave you that example. I'm coming to that in a bit. But first, let's try and understand this. Yeah? So this is done. Now we are coming to the classification of polynomials. So I'm sure you've understood whatever we've covered so far. Yes? If there is any doubt, just ask me that, or let's just spend the time now and ask it. Like the question here is what is the degree of 0 polynomial? Is this a 0 polynomial, by the way? The one I'm writing now, I'm answering Rafiq's doubt here. The example that I've written here, you guys first tell me, okay? You guys first tell me, is this a 0 polynomial or not? Just answer yes or no. Anubha, I'm going to answer your question as well. Difference between 0 and constant. Okay. Is this a 0 polynomial? Yes or no? Okay. Satish, Kanika, Ranjan, Sunil, Gaurav, Vedika, Jasmita. Awesome. Awesome. All of you are saying yes as the answer. Yes. Very good. This is a 0 polynomial, because when I simplify it, the result is going to be 0. Yes. When I simplify it, the result is going to be 0. But let's suppose I leave it like that. Okay? Then, if I ask you the degree, you're going to say degree is 6. Right? Because that is the highest power. If I remove this, you're going to say degree is 5. Alright. If I remove this, then you're going to say degree is 4. If I remove this, you're going to say degree is 3. This is the reason why the degree of a 0 polynomial is not defined. Okay, this is a very important point, and I want you guys to maybe note it down in your books. Okay, and I'm sure you've understood this as well now. The degree of a 0 polynomial is not defined, because it can be anything. Degree of a 0 polynomial is not defined. It's infinite. Yes? You've understood that now, right? So you've understood all the doubts related to 0 polynomial are clarified. Yeah. Now coming to, I don't remember the name. I'm sorry about that. Constant polynomial, right? Constant polynomial, you will have a number. Okay. Like p of x being 7, p of x being minus 9, p of x being 11. All of these are called constant polynomials. The degree of a constant polynomial is going to be 0. Okay, so degree of a 0 polynomial is not defined, whereas the degree of a constant polynomial is 0. So look, I have written both these important points in a box. No. 5 is not equal to 5 power 0. Okay, 5 multiplied with x power 0. I think you misread this. Now, Anubha, I hope your doubt is clarified, right? 0 polynomial, constant polynomial differences. Look, 0 polynomial, I've explained you that. Constant polynomial, also I have explained you that. P of x is simply a notation, okay? We simply say that this is a polynomial, a symbol to designate a polynomial. That's all P of x is, okay? Cool. Let's move on now to the next bit. Classifications. Now, there are two ways in which we can classify that. Either in terms of the number of terms or in terms of number of degrees. Why P of x is equal to? Because 7 can be written like 7 power 1, right? That's a reason why. It can be written like 7 multiplied with x to the power 0 as well. All right, so come on, now let's focus on these. Now classification is done in two ways. First, based on number of terms. Second, based on degree. Now, if the degree is 1, it is called linear. If the degree is 2, quadratic. If the degree 3, cubic. And one of the students also answered, if the degree is 4, what is it called? Yes, monomial will have only one term. Binomial will have 2 terms. Trinomial will have 3 terms. Okay, now I'm going to give you an example and you guys are going to tell me the answer. Now, look at this. 3x cube plus 5x square plus 9. First, tell me the degree of it. Rajesh will come to that in the next class. That is taken care of in part 2, factor theorem. Okay? Alright, first tell me the degree of it. Very good, Sunil, Zarina, well done, Satish as well. Degree is 3, and for this reason I am going to call this a cubic polynomial. First part understood? Very good. Okay. Now you've got to tell me how many terms are there in this. Count the number of terms. I'm sure you guys remember the definition of a term. How many terms are there? Very good. You guys are giving the answer to this, I believe. Yes. So 3 terms, right? What are the terms of this? Terms are 3x cube is the first term, 5x square is the second term, and remember, constant is also considered as a term. This is important. Constant is also considered as a term. So there are 3 terms here, right? And if there are 3 terms, what do we call it? We call it a trinomial. Trinomial. Very good. Now I'm going to bring on a question. Let's see how many of you will be able to answer this. All right. So identify this polynomial now. Tell me if this is based on number of terms. So just count the number of terms and tell me what do you call this polynomial. Is it a trinomial? You guys remember this. You always have to simplify it first. Okay? Simplify it first. Yes, Gaurav, I'm coming to that. Infinite terms, if you keep writing 0, 0, 0, 0, that's the reason why the degree is infinite. Okay? You've got to simplify this first. Look, can I simplify this? Let me just take a better color first. All right, look. 5x square minus 2x square minus 3x plus x. Very good. Now you're saying the correct answers. Because 5x square minus 2x square can be combined. They are like terms, right? So this can be written like 3x square. And then minus 3x plus x can also be combined because they are like terms. And this can be written as minus 2x. Yes? Yeah. Now tell me, how many terms? How many terms? There are 2 terms in it, right? 3x square being the first term, minus 2x being the second term. So this is not a trinomial, this is a binomial because there are only 2 terms here. Okay, because look, if I give you this, x cube plus 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 x cube. If I ask you how many terms are there, what will your answer be? What will your answer be if I ask you how many terms are there in this example that I have written at the top here? How many terms are there? Vedika, very good. Satish, very good. Yes, it is a monomial because I can keep writing. You will not say that this has 1, 2, 3, 4, 5, 6. You cannot say this has 6 terms. When you say there are 6 terms here, you are wrong. Okay? Because I can simplify this. I can write it like 6x cube. Right? And this is the reason why there is only 1 term here. And for that reason, I am going to call this a monomial. Okay? So you have to remember this. This is very crucial. Whenever an expression has been given to you, you have to simplify this by combining the like terms. And then count the number of terms. Alright? Very good. You've understood this, so I'm going to give you some questions now. Alright, tell me the first thing. This is interesting. X power 4 plus 0. What is it going to be? Come on, let's focus on this. Okay, Rahul says if there are 2 variables for a constant, then what is a degree? if there are two variables for a constant? Rahul, you have to give me an example for that. They can't be. That's not possible, right? All right, so you guys are saying monomial. Very good, because x to the power 4 plus 0 plus 0 plus 0 plus 0 plus 0. I can go on an infinite number of times. So 0 is not considered. Very good, very good. So the 0 is not considered. This can be written like simply x to the power 4. And for that reason, this is going to be a monomial. Well done. What about the second one? X square minus 5x square plus 2. What about the second one? X square minus 5x square plus 2. I can simplify this again. Yes, I can simplify this and say minus 4x square plus 2. So look, there are two terms here. So this is going to be a binomial. Very good. Well done. All of you are saying the correct answers to this. All right. So don't be in a rush when you have been asked these kind of questions. Check first whether you can simplify the expression, and only after you've simplified it by combining all the like terms, then make a call. Now this, you can't simplify this because there are no like terms here. No like terms. So it can't be simplified. So this is the reason why this is going to be a trinomial. Okay. All right. So we've understood this, the classification. Rahul, 3xy. 3xy can't be a constant, right? Because there are variables there. That's going to be a monomial, Rahul. 3xy. Okay? Oh, that's what you're asking. All right, all right, all right. I'm coming to that. 3x square y square plus 4x cube y cube. Yeah? I think this is what you are asking. What is the degree of this? Yes? I believe this is what you are asking. Yes, you can do operations on numbers, powers. In this case, what you are going to do here is, all right, add up the powers. Add up the powers. What do you get when you add these two? 4, right? What do you get when you add these two? 6. So I'm going to say that the degree is 6. So you add up the powers. Yes, when the variables are different, this is how you simplify. Very good. Very good. Yes. All right, so we've completed the circle now with respect to these things. Yes, adding up the powers. This is what, valid doubt. Very good, Rahul. Thanks for reminding me this. All right, so we are done with introduction. We are done with terminologies. We're done with degree. We're done with number of terms. Now let's check out these two, value of a polynomial and zero of a polynomial. These are very, very simple concepts. All right, so first let's check out the value of the polynomial. Okay, this is something that we've already covered. Monomial, binomial, trinomial, we've covered it. Based on the degree, identify the given polynomial. Okay, you guys want to give it a try to this? Because all right, no, this is simple. I think you guys can do this. Let's move on to the value. All right, so value of a polynomial. Let's suppose I give you this polynomial, okay? Oh, good afternoon. You're late today. Anubha, please explain the second one again. Which was the second one, Anubha? I forgot. I forgot the second one. Oh, this thing. Look, when you have multiple variables, right, you add up the powers. Like for calculating the degree, let me just write that down here. Let's say I give you 3x cube y square plus x to the power 7 y power 4. I'm asking you the degree for this. Now there must be some confusion because there are many variables. There are two variables, x and y. In this case, what you do is you add up the powers of the variable. The power of x here is 3. The power of x here is 2. You add them up. What do you get? 5. You add the powers here, 7 and 4. What do you get? 11. Which is bigger between 5 and 11? 11 is bigger. So 11 will be called the degree of the polynomial. Okay. I hope Anubha has understood that. Okay, so this is something that we've already covered, guys, based on the number of terms, right? And this is something that you guys can do this as well. So I'm skipping this question and moving on to the value of the polynomial now. All right, so let's say this is the polynomial and I want to figure out the value of the polynomial at x is equal to 2. Okay, there is no terminologies concept. Okay, but never mind, you've learned it because you need to learn it to be able to understand the question. All right, so that's the reason why. Cool. Now, let's say I want to find the value at x is equal to 2. What you do here is, Mayank has given the answer already. You substitute 2 in the place of x. That's all. All right, so in the place of x, if I substitute 2, I will get 10 as the correct answer. Well done. Okay, now let's suppose I want to find the value of P of 3. It simply means that the value of the polynomial at x is equal to 3. Okay? So what do you do now? In the place of x, you substitute 3. So this is 3 square plus 3 plus 4, giving us 9 plus 7, giving us 16. Okay? So value is a very simple concept. Okay? So I hope this is understood. There's nothing much to elaborate on this. So when you want to figure out the value of a polynomial, you simply substitute whatever value you want in the place of the variable and you will get the answer. Okay? So I'm going to move on now. This is called the value. Go ahead, try this question out now. Find the value at x equals 3 and x equals 4. Come on, go ahead and tell me the answers. So you're trying to figure out the polynomial value at x equals 3 and the value of polynomial at x equals 4. Okay, this may take a bit of time, I believe. So in the place of x, I'm going to substitute 3. Okay, Nitin, I'll repeat this again. In the place of x, right, you see this polynomial, right? Wherever you see x, in the place of that, substitute 3. Okay, that's all. So in the place of x, if I substitute 3, I get 3 square minus 2 multiplied with 3 minus 3. Okay, so this is going to be what? 9 minus 6 minus 3. So the first answer is going to be 0. I hope you guys are getting 0 as the correct answer. Mayank, minus 18, minus 27, there must have been a calculation mistake from your side. P of 3 is 0. Yes, P of 3 is 0. What about P of 4? You guys are saying 5 or 4. I'm confused as well. Come on, let's try this out. In the place of x, I'm going to substitute 4. That's all. So this is going to be 16 minus 8 minus 3, giving me 8 minus 3. So there you go. 5 is going to be the correct answer. Yes, well done. 5. So you've understood what value of a polynomial means. It simply means in the place of the variable, you're going to substitute whatever value. Thank you, Nitin. Thank you for that. No, this is for class 9. Yes? Cool. Let's move on now to the last concept, which is going to be zeros of a polynomial. Yeah? So when the polynomial becomes 0 is what we call the 0. Okay? Now have a look at this. I'm going to give you a simple one first. Let's suppose the polynomial p of x is x minus 5. Okay? Now tell me what value I need to put in the place of x for this to be 0. It's a simple question. That's all 0 of a polynomial means. For what value of x will this be 0? 5. The example that I have given. Satish has given the answer to these two. Well done. But the answer to this is going to be 5, right? Because in the place of x, when I put 5, 5 minus 5, 0. So I say 0 of p of x is 5. As simple as that. Okay? Now, how do you figure this out again? First you equate x plus 3 to 0. And then you equate x minus 5 to 0. Alright, so x plus 3 becomes 0 when? It becomes 0 at x equals minus 3. And this becomes 0 at x equals 5. So we say minus 3 and 5 are zeros of this polynomial. Very good, very good. Now I'll give you an interesting one. I'll rub this out first. I'll give you an interesting one now. X square minus 4 is equal to 0. Yep. Tell me for what value of x this will become 0. The 0 will be when? Because when you're trying to solve this is x square is equal to 4 and x can be equal to plus or minus 2. Right? Minus 2 is also valid because in the place of x, if I put minus 2 as well, square of a negative number is a positive number, right? So again you will be getting 0. Alright, so plus 2 or minus 2 both will be equally valid. Because in the place of x you put 2, the result is 0. In the place of x you put minus 2, again the result is 0. Well done. So that was a simple concept, zeros of a polynomial. Now it's homework time. Now I'm sure you guys can easily figure this out. Yeah, p of x is given. You have to find p of x plus p of minus x. Yeah, and let us know the correct answer in the comments box. I'm sure you guys should be easily able to do this. I'm going to move on. For students who have joined us late, I will repeat the advantages of Byjus Premium classes once again. The whole advantage revolves around the process of personalization where you have a tutor simultaneously to take care of all your doubts. Okay, so one tutor is there to take care of all the teaching, the concepts and all, and then you have another teacher who's going to clear off all your doubts. Okay, and then map to the school curriculum. You can choose your own class timings. This is going to be pretty fantastic, I assure you of that. The link to this could be found in the descriptions box. Make sure you join it, because if you like my style of teaching, I'm sure you will love the Byjus classes as well. And again, the Telegram channel, you will find the link to this in the descriptions box, because this is where session notes will be shared with you. And of course, we've got you covered. I'm sure you guys know about this. We're coming up with plenty of good sessions. Now, the second part of the polynomials is going to be on Thursday, 4 p.m. Be ready for this. Don't miss out this session. And the last thing, guys, if you've liked what we've done for you today, if you've understood every concept that we've covered today, hit the like button. It'll mean a lot to us, okay? And share it with your friends as well. And in case there were any new students joining us through this video, please make sure you subscribe to the channel. And I'll meet you again in the second part of polynomials. And one suggestion before I call this off: whatever we have covered today, please make sure you revise it. Watch this video again, prepare your own notes. These notes will any which ways be shared with you, and practice as many questions as you can. All right? That way, we can be perfect that in saying that, hey, good, I'm amazing with part 1. And when part 2 comes, we will repeat the same things again, because this is an important chapter and I want all of you to understand this to its depth. Okay, so thank you for your time. You've been amazing in participating, typing out all your answers. So you've been amazing. Yep, awesome. So cool, guys. I'll see you for the part 2. Till that time, take care of yourself. Bye bye.